Hello friends, and now we are going to discuss about the Otto cycle efficiency. So what we are going to derive is Otto cycle air standard efficiency is equal to 1 minus 1 upon R raised to gamma minus 1, where R is the compression ratio, which is nothing but V1 divided by V2. The Otto cycle efficiency PV diagram is uh, drawn here, and 1 to 2 process, 2 to 3, 3 to 4 and 4 to 1. But in case of 1 to 2 process, adiabatic process it is, and work done upon the system. 2 to 3 is combustion process, in which heat is supplied into the system. 3 to 4 is adiabatic expansion process, work is done by the system, and 4 to 1 is constant volume heat rejection process, where heat is rejected at a constant volume. So process number 1 to 2 is the adiabatic process, and whenever we are hearing this equation adiabatic process, the first equation comes in my mind is, so whenever we are hearing this adiabatic process, at that time one equation comes in our mind, which is T2 by T1 is equal to P2 by P1 raised to gamma minus 1 upon gamma is equal to V1 by V2 raised to gamma minus 1. But before proceed further, let's have a glimpse of what do we mean by efficiency. Efficiency is nothing but output divided by input, means work done by the system divided by heat input, and work done by the system one done by the cycle is equal to the heat interaction between the cycle as per the first law of thermodynamics. So instead of W net, I am writing here Q1 minus Q2, and ultimately the equation is 1 minus Q2 divided by Q1. Now the Q2 is a port 1 process, which is constant volume process. So instead of Q2, I'm putting the equation of MCV T4 minus T1, and Q1 is the process number 2 to 3. So instead of Q1, I'm putting the equation MCV T3 minus T2. MCV cancelled out. The equation would be 1 minus T4 minus T1 divided by T3 minus T2. So now converting all the equation in terms of T1, means T4 in terms of T1, T3 in terms of T1 and T2 in terms of T1. How to do that? Let's come to the process. Process number 1 to 2 is adiabatic process, and for the adiabatic process, the equation is T2 by T1 is equal to P2 by P1 raised to gamma minus 1 upon gamma is equal to V1 by V2 raised to gamma minus 1. So using this equation, T2 by T1 is equal to V1 by V2 raised to gamma minus 1, and V1 by V2 is nothing but the compression ratio. What it physically means? It physically means then whenever the piston, suppose this is the cylinder top and this is the piston. So whenever the piston is at the top dead center, the remaining volume is V2 volume, and whenever the piston is at the bottom dead center, the throughout volume is V1 volume, because from in case of 1 to 2 process, piston is moving from bottom dead center to the top dead center. So from bottom dead center, whatever will be the volume, that is V1, and from the top dead center, whatever will be the volume, which is also known as a clearance volume, that is V2. So V1 by V2 is nothing but the compression ratio, and T2 by T1 is equal to R raised to gamma minus 1, and T2 is equal to R raised to gamma minus 1 into T1. So now T2 is converted in terms of T1. Let's talk about the process number 2, 3, which is constant volume process, and whenever we are having constant volume or constant pressure process, at that time we need to use this equation P2 V2 divided by T2 is equal to P3 V3 divided by T3. So here we are knowing that V2 is equal to V3, so P2 divided by T2 is equal to P3 divided by T3, and T3, making the equation of T3, P3 by P2 into T2, and P2 is what? R raised to gamma minus 1 into T1. Sometimes the student having difficulty in case of constant volume process and the adiabatic process. So keep in mind that whenever there is an adiabatic word used, we are going to use such equation. And whenever there are constant volume and constant pressure processes there, we are using this equation for deriving the turbine value, the temperature value. Process number 3 to 4 is expansion process, but it is adiabatic expansion. So now, as the adiabatic word used, the T4 by T3 is equal to P4 by P3 raised to gamma minus 1 upon gamma is equal to V3 by V4 raised to gamma minus 1, because it is process number 3 to 4. That's why we are using 4 and 3 instead of 2 and 1. So T4 by T3 is equal to V3 by V4 raised to gamma minus 1, and V3 is nothing but V2, because 2 to 3 is constant volume process, and V4 is nothing but V1 because it is also constant volume process. So V2 by V1 raised to gamma minus 1, instead of V3 we are putting the value of V2, and instead of V4 we are putting the value of V1. So it is inverse of the compression ratio 1 upon R raised to gamma minus 1. So T4 is equal to 1 upon R raised to gamma minus 1 into T3. T3 is nothing but P3 by P2 R raised to gamma minus 1 into T1. So R raised to gamma minus 1, R raised to gamma minus 1 cancel out, and the remaining equation is P3 by P2 into T1. So now, as per the efficiency, now putting all the values of T4, T3, T2 in a single equation. So what we have obtained is, instead of putting T4 instead of T, putting value of P3 by P2 into T1 minus T1 divided by, instead of T3, putting the value P3 by P2 R raised to gamma minus 1 into T1 instead of T2 R raised to gamma minus 1 into T1. Then from the numerator taking T1 common, remaining part is P3 by P2 minus 1. From the denominator taking R raised to gamma minus 1 into T1 common, the remaining part is P3 by P2 minus 1. P3 by P2 and P3 by P2 minus 1 from the numerator and denominator is cancel out, and the remaining equation is 1 minus 1 upon R raised to gamma minus 1. The main thing in this equation is it to be known that the efficiency of the Otto cycle, the air standard efficiency, it is not actual efficiency, it is air standard efficiency, means you are thinking that air is only supplied in the Otto cycle, and uh, this efficiency is depend only on the compression ratio. It is a function of compression ratio only, because adiabatic index value is constant 1.4. So if the compression ratio increases, this value decreases and efficiency increases. That means as the efficiency ratio increases, efficiency increases. The compression ratio increases, efficiency increases, and that is the conclusion of this Otto cycle. I hope you thoroughly enjoyed this study. Have a nice day.